Okay, question 3. The good thing about these questions is they do build up to where they're through the process of the thinking of how absorption takes place. You see, because here we simply have scenario, we have 3 products, which is how you would really teach this, really. 3 products, and this is a classic case of what I was just talking about, just spreading it based on machine hours, for example, or labor hours. So here it tells us that um, you to make budgets to produce, you have 10 units of X, 20 units of Y, and 30 units of Z. And then it tells us that you um, take, um, where is it? It takes 5 hours to make a unit of Z, and 10 hours to make a unit of Z, and 5 hours to make it, sorry, 10 hours to make a unit of Y. That's right, yes, and 5 hours to make a unit of Z. And when it's telling us you have £10,000 overall, this is all budgeted, but it's the same principle. And we're trying to understand, well, what's the total of all my overheads hours, or all my machine hours. So basically I'm saying that 10,000, that all these hours here drove or caused £10,000 of overhead. So the question here is then, what is the overhead cost per hour, which is really referred to as the overhead absorption rate. So ultimately it's the 10,000 divided by the 50 plus 200 plus 150, which is 10,000 over 400, which is 25. Right? Is 25. So this is your overhead absorption rate. This is kind of like I mean, this could have been material, right? You need 50 kilograms here, 50 kilograms, and you're going to spend 10,000. How much is it per kilogram, if you like? That's really, so technically this is, and you would have called that your direct material cost per hour, if you like, right? That's what you would have said. But we're just dealing it with overheads, because we want to assign a full cost. So direct materials, direct labor, and overhead to making a unit. So that's your full cost, isn't it? Direct material, direct labor, and assigning the relevant overhead. And to get the full cost. And if you're making an item, this is what we refer to as standard costing. If I'm trying to cost inventory, the standard allows me to find the full cost of making something and putting it in my inventory, and it must include the production overhead. This is production overheads anyway. I think they tell us very much in the factory. Okay, great. Let's look at the next question. Right, and so here, interesting this. Now, you remember the issue here was we looked at several ways. The problem here was that in a happy world, we would have A, B. Imagine this were my production departments, and then I would have C and D. And these departments are not production. I mean, they're in the factory, but they don't make units. Now, it'll be wonderful if, for example, it just said that, okay, here is £10,000 and here is £20,000, and C does work for A and B, and we can split that work based on a 50% ratio. So C will basically just take this thing and split it between here. That would have been 5,000, and that would have been 5,000. And they said D does its own via a 10% for A and then 90% for B. So I'd have literally just done the 2,000 here and 18,000, and I'd be done, and I'd be away, right? But that's not always the case. C might do some work for D, D might do some work for C, so we have a problem. You see, because the question here is that I can't just naturally split it between the two, because if it said that, oh, C does, imagine it said the C did actually 50, 40, and 10. What I would then be doing is say 50 here, 5 here, 4 here, and 1 here. You see, so the question here is, okay, well, now I need to, then it says, if it said the D did um, um, 10%, 80%, and 10% here. By the time I take this 21, I would go split 21 via 10% here, which is 2,100, 80% here. I'm just going to make this up, 18,000, 17,500, and then again 2001. Actually, I can find the 2001, 2001, 4,002. 4,002 from 21 gives us 15,800. So imagine I did this. I could look at it this way. But now I suddenly have C again, and then I have to keep on going. So you see, the problem is that immediately you have two service departments working for each other, we have a situation where we have to continuously keep going until we totally get rid or fully reapportion the costs in C and D to A and B. And that's what we talked about, if you remember this question about repeated distribution methods and specific order of closure, where we're trying to get rid of these costs out of here. So let's look through. Really, the answer here is that when we do this, when we have decided to use repeated distribution to reapportion service department costs, is because you have service departments that are carrying out work for each other. Really, that's really the case. Ultimately, that's the fun. I mean, all these are not true. These are just different scenarios for different things that mean nothing really in relation to this issue of these methods of repeated distribution. And there was the algebraic method as well. So really, what I want you to do, definitely, please, is to watch the videos again. Just watch the sections on that, on the algebraic method, the specified order of closure, and the repeated distribution as revision. So it's good. It's good work. Please do that. But just shows how we get rid of these, and it's just really a system of getting rid of these costs, because ultimately our aim is to cancel the overheads here and make sure all the overheads go into A and B, so we can then go on to absorb into the units in A and B. Okay, great stuff. See you in the next video.